So this is common base configuration. So this is the circuit and the input characteristic, common base input characteristics and output characteristics we are going to discuss. But let me first discuss about the input characteristics. And this is the circuit, this is the emitter base collector, and this part input port is connected in forward base because this is PNP transistor. So emitter base collector, this emitter is connected to positive, so P to P positive to P, that means forward base. Similarly, this negative voltage of the battery is connected to PNP, so collector is P, that means it is reverse bias. So this is the at origin the circuit is being connected. Then and this is the constructional view of the it's PNPN transistor. So emitter base collector, and this is emitter, and this is the base, and this is the collector. So that means these are having holes, more number of holes, free electrons. So free holes are there, free holes are there. In this, it's a low concentration. So less number of electrons are there, less number of electrons, and it is moderately concentrated collector. It is highly concentration, moderately concentration, and very low concentration. So that's why high number of holes are there, moderate number of holes are there, and less number of electrons, majority carriers, since it is in N-type. So let us check for VCB is equal to 0. So we are going to draw the graph between input voltage, this is x-axis on the input voltage, and y-axis current, input current IE on the y-axis. So this is the graph is going to be drawn between. How? Let us check. First it is we are draw the graph between this is IE emitter current and this is VEB voltage between emitter and base. So let us initially VCB is equal to 0, this voltage is equal to 0 because this is VCB, this voltage is equal to 0. That means voltage between the collector and base is equal to 0. So what will happen if the positive is connected to the hole? So we have more number of holes there. Holes are repelled into this, and that means holes are moving towards this because this voltage pushes the holes into this. So then these more number of holes are entering into the base region. So that's why it is called as a base. That's why it is since it emits majority carriers, so it's called as emitter, and all emitter holes are entering into the base region and stayed sometime. If it is a NPN and we need to connect it is forward bias, means we have to give negative voltage to this N, so that more number of electrons are going into the base, where the base is P-type and the collector is N-type. So what might be the PNP or NPN transistor, but the principle of operation is same. So majority carriers are entering into the base region by giving a positive voltage here or forward bias here. Then all holes are entering into this. So let us assume that the number of holes are 20. Then here the number of majority carriers of electrons are 5 because it is a very less doping concentration, 5. And let us here the majority carriers of holes are 15. Let us say the number 20 holes, 5 electrons, and 15 holes. Let's say suppose. Then the 20 more 20, by giving a full voltage, as the voltage is giving, then the holes are moving towards first. Let us move first hole, second hole, third hole, fourth hole, fifth hole, like 20 volts by giving voltage, so that all 20 volts are giving gradually into the slowly into the N region and stayed sometime there. 20 holes are be here, and already 5 electrons majority carriers of base are there. So 5 electrons and 5 electrons are recombined with the 20 number of holes which are coming from the base, which are coming from the emitter. So 5 electrons are neutralized, then 15 holes are available here. So here the current is, since it is a PN junction, it seems to PN junction, so we have an equation. What is the current equation? I is equal to I naught into e power v by eta vt minus 1. Already we have discussed in the last video, in the semiconductor video, PN junction diode video. The current equation is this. This is the current equation. This is VEB, this is VEB, eta VT. Eta is the diode constant. So as the giving the voltage VEB, the VEB increases, current is exponentially increases with respect to the current. So that's why for VCB is equal to 0, the current is exponentially increases, as in the case of diode equation. So, and next case, and second case, VEB here, let VEB is equals to because and it's a reverse bias. Reverse bias mean because p type means this is n positive here. So this is VCB. So let it be 5 volts. Keep the 5 volts here. So keep the 5 volts here means because this diode is connected reverse bias. So definitely depletion width is penetrating in this, and similarly depletion width is less penetrating into this region and more penetrating into this region. This is the depletion width, and this is the depletion width in P region. That means this part is more and this part is less. That means the width in base is high, whereas the width in base in collector because more penetrating into this. So what will happen? So initially, that means initially we have 5 number of electrons are there, but due to neutralization by giving a reverse voltage to this, assume that instead of 5 volts and 2 are neutralized in the depletion width. So only assume that 3 electrons are available here. Let us say. Then by giving this voltage, positive voltage, and 20 holes are coming into this, and in the past case when the VCB is equal to 0, here we have 5 number of electrons. 5 number of electrons are recombined with the 20 number of holes from the P side. So now 3 electrons are available and 3 are recombined with the 20 holes with this. Then now the holes available in the base are 17. So in the previous case when the VCB is equal to 0, holes available are 15. But now here the 17, that means more number of hole charge carriers are there, then automatically conduction, all holes are attracted towards this because it is a negative. In these holes and which are stayed already in the base, they are entering into this region, starts giving current. So same, this is high into in the shape of I is equal to N. That means it's more current is there. So that's why when VCB is equal to 5 volts, then this current gives more current. That means slope is bending towards y axis, more current when this 5 volts is given. Let us next coming to let us check when VCB is equals to, put this value is equal to 10 volts, then what will happen? 10 volts means this PN junction is connected in the reverse bias. It is more penetration, that means the penetration of the depletion width is more into the base. That means, okay, no, it is more penetrating into this. So in this only less. So that's why the width is very more. The width is this penetration of width is very high in this. But this is what is called as effective electrical width of the base. In the past case when VCB is equal to 5 volts, assumed 3 number of electrons available. But now since the depletion width is more, so neutralization has been taken place. Instead of 3, now we have only 1 number of electrons are available in the effective electric width. But as the VEB forward voltage is given, 20 holes are entering into this. Among 20, 1 is neutralized, 19 as remaining as a free holes in the base, and which are collected into the collector because of this reverse voltage. Because of this reverse voltage. So that's why now in this when VCB is equal to 10 volts, huge amount of currents has been transferred because now 19 holes are there and 19 holes plus these holes, totally the current has been transferred. So that's why when VCB is equal to 10, huge amount, that means slope is increases x. So thus when input voltage VEB is increases, I is increases, initially the current is increases as in the diode equation. When VCB is equal to 0, no current, no voltage here. When VCB is 5 volts, then due to the depletion width is decreases and the effective electric width is decreases, depletion width is increases, then the current is increases because whole neutralization in the base is recombination rate is increases in the base. So current is more, that's why more current is increases than this VCB is equal to 0. But still if VCB is more, then neutralization is in the base is recombination is more increases. So availability number of electrons in the base are decreases, majority carriers electrons decreases, huge amount of holes are transferred into this collector. That's why more current is being traveled when VCB is equal to 10. Thus the current is increases than the previous. Coming to the output coming to the output characteristics, this is output characteristics of uh, uh, common base configuration. So their output parameters are IC, output current, and VCB. That means collector to base as the output port. So take VCB on the x-axis and IC on the y-axis, and this is the way of connection of output character. Means input is forward bias, output is reverse bias, and we have a current equation for the output current equation. IC is equals to alpha times IB plus IC naught. This is called reverse saturation current. So where alpha is the current gain, that is IC by IB is the current gain, and IC naught is the reverse saturation current. So in this one, another important point is alpha value is approximately equal to alpha. Here alpha value is approximately equal to maybe 0.99, its variation 0.98 or in the region of 0.98 to 1 in between approximately. So that's why, and similarly IC naught is in order of milliamperes, in order of microamperes, germanium in the case of, and similarly nanoamperes in the case of silicon. So we can neglect this value is equals to this IC naught is reversed. So and similarly, so alpha, since this value is almost approximately equal to, then IC is approximately equal to IB. So what might be the value of input current is given, that should be the IC. That means it is clearly said that it is completely independent on VCB. So what might be the voltage? This reverse voltage is given, but the current traveling through this is independent on voltage. If 0, same voltage. That means the passing of this IC, that means this is the collector current, is independent on VCB. So that depends only on the IB only. So that's why if input is first, let this value is equal to, keep this value is equal to something, so that input current is equals to here 0. First open circuit 0. That means, so what should be the output current? IC is equal to 0. So that's why 0 for 0 microamperes. And similarly, if input is equal to 10 microamperes kept here, IC is also 10 microamperes, because that's why it is constant. That means here, so 10 microamperes here, 10 microamperes, this is 0. That means there is a region is there actually, but something, some IC not that value, IC not is equal to microamperes. So that's why we cannot seem to be a coincidence each other, but it's for time being only. And similarly, this is 20 microamperes, this is the 30 microamperes. So for IB 20 microamperes, constant 20 microamperes current is there. 30 amperes current is there. What might be the value of input IB? So because of this formula, IC is equal to IB approximately, the same value will be appear. This is how the output characteristics of this. And this part is cut off, and this part is saturation, and this part is from this part is active, and this part is saturation. This region is saturation, cut off, and this is active. So this is the output characteristics of common base. The key point is IC is approximately IB. What might be the value of given as IB? The same will be IC. If 0, 0, 10, 10 micro, 30, 30 micro, 40, 30, 40, whatever, same value is there.